Hello students, today we are going to see chapter number 6 and from that stress and strain for 11th science. So, stress and strain. What is stress and strain? These are the properties of the solids. Just we had seen the properties of solids, that is elasticity and plasticity are the properties of solids. Then what is elastic material? What is plastic material? But in this case, when there is elastic material, that means they regains their original dimensions. But since there is change in dimensions, if it is in size, shape or both, area, volume, and from that that is concluded in stress and strain. Okay. So stress is nothing but it is the ratio of deforming force per unit area or internal restoring force per unit area. Therefore, stress can be given by it is the ratio of restoring force per unit area, or it can be written as deforming force per unit area. Okay. If there is change in length change होत असेल तरी सुद्धा त्याला काय म्हटलं जातं, व्हॉल्यूम चेंज होत असेल तर त्याला कुठला स्ट्रेन म्हटलं जातं वगैरे. सो दिस कॅन बी रिटन इन दिस वे. Suppose deforming force A bar by area. So stress can be defined in this way. What is its unit then? Since stress is equal to F bar by A, we know unit of force is Newton, capital N, and area, that is nothing but meter square. Therefore, totally unit of stress is given by Newton per meter square. What is unit of stress? It is Newton per meter square, or it is also called as a Pascal. याला equivalent to Pascal, or it is also called as a pound. What is dimensions of stress? Dimensions of stress, it is force upon area. Dimensions of force is equal to what? Force is nothing but force is equal to mass into acceleration. Therefore, m raised to 1 acceleration, velocity per unit time. Therefore, l raised to 1 t raised to minus 2 divided by area. That means l raised to 2. Therefore, totally dimensions of stress becomes that m raised to 1, l raised to minus 1 and t raised to minus 2. These are the dimensions of stress. Then there are types of stress. From that, first one is tensile stress. What is, or it is also called as compressive stress. That means, understood all of you? What is stress? Restoring force per unit area. Now strain, both quantities we looks like as the same, stress and strain, but there is some difference in between them. So what is difference in between them? For that purpose, strain is nothing but, or strain can be defined as it is the ratio of change in dimension to the original dimension. Strain can be defined as change in dimension to the original dimension. That means whatever may be the change in dimension, that is the value, original value to the change in value. Okay. So it is unitless quantity. It is unitless since change in dimension to the original dimension. That means both of quantities are of same unit, therefore it is unitless quantity. Okay. Then types of stress and types of strain. For that purpose, suppose consider there is a wire is of length L. Suppose length L. ही एक वायर घेतली जिची लेंथ काय आहे स्मॉल L आहे. Initially, when we apply some force on it, then त्याला काहीतरी आपण force apply केला. That means suppose weight W is equal to M into G, force apply केला. Then what happened? Its length changes. Its length changes, and the change in length is equal to, that means suppose this is equal to delta L and this is L. Original length, then the change in length is equal to delta L and the original length is L. Therefore, final length is equal to delta L plus L. मग strain जर define करायचं असेल तर इथं काय म्हणता येईल आपल्याला? Change in dimension to the original dimension. कुठलं डायमेन्शन बदललं? लेंथ बदलली. मग कितीने बदल झाला चेंज इन डायमेन्शन? डेल्टा एल टू द ओरिजिनल डायमेन्शन, that is L. Okay, in this way stress and strain can be defined. Now types of stress and types of strain. Types of stress. From that, first one is tensile stress, or it is also called as compressive or compressive. Compressive stress. Okay, so what is tensile stress or compressive stress? In this, where there is change in length, which dimension changes? Dimension is length. When there is change in length, then it is called as tensile stress or compressive stress. In this case also, what is the formula for this? It is equal to, or tensile stress is equal to applied force or deforming force per unit area. Once again, it is equal to F bar by A. Once again, its unit Newton per meter square. Once again, its dimension m raised to 1, l raised to minus 1, t raised to minus 2. ठीक है? हा झाला टेन्साइल स्ट्रेस और कॉम्प्रेसिव्ह स्ट्रेस. मग असंच दिलेलं एक्झाम्पल वायर दिली किंवा एखादी वायर दिली पाठीमागे फॉर एक्झाम्पल इन दिस वे. तिचं काय होतं? लेंथ इंक्रीज होते म्हणजे तिचं डायमीटर कमी होणार आहे. इफ दिस इज अ वायर which having initial length L or small l, and afterwards when we apply some force on it, then its length increases and it is suppose equal to small l and delta L. Okay, in this way this is increasing length by applying force on it. Then in this way there is the change in dimension, that is length. वायर घेतली तिला आपण काही फोर्स अप्लाय केला तर काय होणार आहे? तिची लेंथ वाढणार आहे. ओके, सो दिस चेंज इन लेंथ and this is original length, this is final length and this is called as tensile stress. Similarly, tensile strain, types of stress म्हटलं मी इथं म्हणते types of strain. Types of strain, त्याच्यामध्ये पहिला येईल tensile strain or tensile strain. Listen carefully. What is it? It is nothing but change in dimension to original dimension. So what is change in dimension? कितीने change झाला dimension? That is delta L, original dimension L. So this is type of strain, tensile strain. Similar tensile stress as well as tensile strain. Since the definitions are different, its values are different. This is the first case. The second one is that is volume stress. Second one, volume stress or hydraulic stress. Volume stress or hydraulic stress. What it indicates? When there is change in dimension as a volume. That means the volume of the solid changes without change in its shape. Then that time it is called as hydraulic stress or volume stress. In this case also, this volume stress is equal to applied force per unit area. Same unit, same dimension. What is the example of this? Suppose consider there is a block having, then if the force from all the directions is applied on it, then it compresses and its final, suppose this is P, this is delta P. By applying force, okay, it becomes delta P. That means there should not change in its shape, only volume it compresses. Its volume changes, but there should not be change in the shape. Such type of change is called as volume stress or hydraulic stress. Then second one to this side, volume strain. Volume strain. What it indicates? It also indicates change in dimension to the original dimension. In this case, this example is also important, whereas this one, its original volume is suppose this is body. Original volume is V, change in volume is delta V. Then by using this, we can write volume strain is equal to change in dimension, that is delta V by V. It is unitless quantity. This is volume stress and volume strain. Then third one is that is shearing stress. What it represents? Third one is that is shearing stress. When there is change in shape of the body. Change in shape of body. In this case, the force applied on that body is parallel to that one. That means consider it is a cube. Front side of a cube. Then the force is applied on parallelly on this one. On this side, then suppose this A, B, C, D. What happened? In this case, this changes or just slides this one layer, the upper layer, C dash, D dash. That means your change in length is delta L to the original length L. And in this case, when there is change in shape of the body, then it is called as a shearing stress. In this case, shearing stress is equal to tan of theta. Or we can write at first, that is applied force per unit area. Okay, but in this case, this force which is tangential force per unit area. This tangential force which is applied on this. So this delta L and this is original length, they are delta L to the L. Force which is in this direction, that is F bar. Okay. So this is called as shearing stress. Once again, its dimension and unit is same as that of the tensile stress, that is Newton per meter square. Then what is third one? That is shearing strain. Third one factor, that is shearing strain. Shearing strain. What it indicates? It indicates change in shape. Change in shape to the original shape. Original shape. That means this layer we can write d dash divided by a d. This can be written in this way: d dash divided by a d, which is equal to c dash divided by b c, and this is equal to totally tan of theta, and therefore shearing strain can be written as tan of theta. Okay, these all are the types of stress and strain.